Howdy everyone, I'm Aisha Smith, and I'll start us off by introducing our boat trip project and explaining the main issues we've investigated throughout the semester. We've been working together all semester, investigating and introducing ourselves into these issues, and these are our duties that we've been abiding by the whole semester, which have helped us keep us on track and prevent us from having any issues within each other. While surveying various locations around Galveston and Pelican Island, we discovered significant corrosion issues along the coast. Corrosion might sound just like a cosmetic problem, but in coastal areas such as Texas A&M Galveston, Pelican Island, and Galveston Island, it directly threatens the durability and sustainability or safety of structures like ships, piers, and other offshore platforms. Corrosion happens when materials, mainly metals, react with environmental elements like water and oxygen. In seawater, this is worse due to salt and especially chloride ions. These ions make protective coatings less effective and accelerate rusting. So how does it work? Scientifically, this is an electrochemical reaction. Seawater acts as an electrolyte, and on a metal surface, different areas act as anodes and cathodes. At the anode, iron atoms lose electrons and become iron ions to form hydroxide ions. These combine with the iron to form iron hydroxide, which eventually turns into rust. So corrosion isn't just a nuisance, it's chemistry in action with serious consequences, and that's what motivated us to look into more solutions and come up with our own. These are currently the most common and most paid for in the US, and the other two, will go over these and continue on.
Hi, I'm Eva Collins, and I'll walk you through the ideas we proposed and what we discovered in the field. Based on what we observed, we developed several proposals to reduce or prevent corrosion. One idea was to upgrade the materials used in wave and tidal turbines, making them more durable and energy efficient. Another was to redesign offshore drilling platforms using corrosion-resistant systems, reducing environmental impact and long-term costs. On Pelican Island, we found sulfur deposits that have been harming marine life and water quality, so we suggested filtering sulfuric acid from the environment and using acid-resistant pipes to prevent future damage. We also proposed building boats from rust-resistant materials and even creating a device that can neutralize ocean acidity by converting excess acid to carbonates, helping rebalance the ocean's pH. During our fieldwork, we recorded GPS coordinates of the place to be surveyed, and all three of these pictures serve to show the impact of corrosion on structures in the ocean. A standout moment was discovering the SSS Selma shipwreck, a giant concrete-hulled ship that shows visible signs of wear and tear from decades of exposure. It really brought the corrosion issue to life.
Our research was guided by sources explaining corrosion prevention techniques. For example, cathodic protection uses a more reactive, sacrificial metal to take on the corrosion instead of the protected metal. These strategies gave us a deeper understanding of what works and what doesn't in harsh marine environments. Now I'll be explaining how corrosion affects the environment and economy, and how we applied the engineering process to find the effective solutions. Corrosion causes massive financial and environmental problems. For example, in the US alone, we spend over $276 billion every year on corrosion-related maintenance. It impacts industries like shipbuilding, energy, and underwater infrastructure. When corrosion goes unchecked, it leads to equipment failure, pollution, and safety hazards. So how should we respond? First, we need to use corrosion resistance materials whenever possible, like fiberglass, composites, or treated metals. For metals that are still vulnerable, protective measures like coatings, cathodic protection, and smart design choices are critical. And we should continue researching ways to improve existing materials so they're better suited to harsh ocean environments. So we use the engineering design process to guide our project. We identified the problem by observing corrosion in coastal areas. Then we imagined solutions and planned by researching prevention methods. We created design ideas like our rust resistant boat and ocean acidity absorber. We tested these ideas based on the cost, feasibility, and environmental impact. And finally, we improved them by selecting the most practical and impactful ones. So overall, in the end, our project highlighted that corrosion isn't just a science problem. It's an engineering and an environmental challenge. With the right innovations, we can protect our ocean coasts and marine infrastructure in our oncoming future. Thank you.